You guys, thank you for coming. My name's Christian Choi. I'm the founder of Emergent Entertainment, and I'm a designer. I'm also a fabricator. We do all sorts of scenic lighting, visuals, kind of everything all in one. And I'm going to just go through kind of how I started and sort of my path of how I got here in the industry today. So thank you guys for coming. And we just kind of put this together, so bear with me. I'm here with my assistant, Martha. Martha helped a lot with this presentation, so I'm going to try to stumble through it. If you just give me a second. I started back in 1988. I started as a spotlight operator in Las Vegas. So I really did start kind of from the bottom of things, and took a path through that led me to eventually touring with Michael Jackson when I was 26. And I got to tour around the world with Michael Jackson, which was really quite an experience. And after that, I did quite a lot of different tours, and eventually ended up doing a tour with Cher. And this was kind of a pivotal moment in my career because I was working with Patrick Woodruff, who did the Rolling Stones, and he wasn't able to be in the United States at the time. So I did a lot of sort of legwork for him and a lot of drawings, and I also did a lot of WYSIWYG work, taking Mark Fisher's set, which you can see in the background there, and putting it into WYSIWYG. So you can see kind of this sort of staircase area here. You know, we took that and mapped it into WYSIWYG, and it was really one of the first tours that I ever did that with. So I got some experience drawing Mark Fisher sets and doing a lot of lighting design and lighting drawings and trussing drawings and rigging drawings for Patrick, and then he flew out and we did the show. Well, they were going to do an HBO shoot of the show, and that was in, I think it was in 2000. They actually aired it, but it was in 1999 that we did the shoot. Incidentally, I was nominated for a Primetime Emmy, which really launched a television aspect of my career. And from then, I did a whole bunch of other shows with Alan Branton, who was the HBO LD for Cher. We did shows like the Dixie Chicks and Madonna Drown World Tour, MTV Icon, the VMAs, the movie awards. And I did, I think, 4 movie awards and 4 VMAs with him. And throughout the VMAs and movie awards, I started using WYSIWYG quite a lot as a sort of a previs tool, just to get an idea of what the lighting would look like, push out a couple renders. And so I was taking a lot of the 2D drawings that I would get from Mark Fisher and turning them into 3D sets, lighting them somewhat, just a little bit, and sending them off. And everybody got really impressed by this. They really, really thought it was a useful tool, so ended up using it more and more. And eventually, I think I kind of outgrew the capabilities of the modeling in WYSIWYG. At the time, it was really, wasn't like it is now. It didn't have as much capability in terms of modeling. So we went on to do another VMAs, I think it was that year, and I decided I was going to try something different. I was going to get into doing 3D Max stuff, which was a lot more of an advanced modeling package, but it gave me some really stellar, stunning rendering power and modeling power as well, and I was able to push out hyper-realistic looking, these are all renderings, in a fraction of the time as well. So, I mean, if you can imagine going from the WYSIWYG renderings to this, it was a dramatic jump, a quantum leap in quality for everybody. So this was Roy Bennett's set, and again, I had all the 2D set drawings. Back then, most of the set drawings were in 2D, and I would just transpose them into 3D Max and bring out all the 3D aspects and light them. And it gave me a lot of experience drawing sets, I suppose, because I really, at this point, only had experience drawing lighting packages. From there, something interesting happened in 2003, and I was introduced to Catalyst, which was Media Server. And since I had already been doing 3D Max stuff and WYSIWYG stuff and a lot of modeling and rendering and things like that, I got heavily into media servers. And I was the first one to use a media server on a broadcast. And that was quite an interesting experience. And I really enjoyed it. So I went on to do a lot of media server work with Catalyst. And one of the big shows that I did after that was the Radio Music Awards, which was another sort of pivotal moment because it showed a lot of people that lighting could do media on a professional level in a live broadcast. And I went out and I filmed all this stuff. I mean, I did a lot of custom content. I did a lot of custom stuff in 3D Max. I also did a lot of filming just around LA, you know, using those films and cutting them together. And this was, this was at a time when all the video guys were doing all of the media server based stuff. And so it was kind of a political nightmare for me to get into, if you could imagine. I mean, it's not like it is now where it's kind of widely accepted that lighting is or the media guy is doing the media servers. It took a lot of paving the way for that, and this was kind of the test bed for that, and it was successful. Here's just a couple more of the pictures of that show, and that's Beyonce and Jewel, all sorts of performers, and a lot of custom content. Very little boxed content I had on that show, canned content. This is another Jewel performance. And as you can see, I mean, everybody saw that, okay, this is the way to go because the set can change dynamically with all of the media server stuff. And it was pretty incredible time. So from that, I was doing media server and lighting at the same time, programming lighting and the media server stuff at the same time. So we were asked to do Super Bowl halftime show. And this is the Super Bowl halftime show that Janet Jackson was on, had the little wardrobe malfunction. I was programming the lighting as well as all of what you see here is the versatiles, and let me see if I can, so versatiles, then the arena, stadium, or whatever it was, all of their internal video elements that they have to do advertisements. We put all of our Catalyst feeds out to those. So I had, I think, 6 outputs on this show, and I knew nothing about the wardrobe malfunction, just so you guys know. I was supposed to black out, and I blacked out when I was told, and everyone still saw it. So anyhow, let's just see here. So this is the show as it was happening, and it was a Mark Fisher design for the set, and Alan Branton designed the lighting, and I was operating both lighting and did all the visuals for the tiles and the rest of the system. I believe this is the moment before. So from this point, there was a group out of California called Asia. Asia, they're a Vietnamese DVD production company. They produce DVDs, like maybe 4 or 5 a year. They're higher end DVDs. Well, they had read all these articles that were coming out about what I was doing with media servers at the time, and they really wanted to work with me. And it was my sort of transition into doing my own lighting design, under my own name, my own video media server stuff under my own name. And so I saw it as an opportunity to, and kind of a springboard. It's a smaller company. It wasn't like a real high profile thing, but it was still high profile enough that we were using all the same equipment, and the directors and everybody was that was on it were heavy hitters in terms of design. I wasn't doing a set at this stage for them. This was John Calkins, but this was the first show that we did up in Cupertino, California, and it was really quite simple. It was just I believe it was 3 channels, 3 outputs, so I could kind of do a screen blend across using Catalyst. And I was able to get a lot of really pretty interesting looks that reflected their music, which is Vietnamese music. I don't know if any of you guys have heard it. It's quite peaceful and Asian sounding, and I mean, so I went to like Huntington Beach, or not Huntington Beach, Huntington Gardens, or it was there's an Asian sort of garden in Pasadena that I went to shoot a lot of this stuff. And I also went up to Big Sur and I shot a bunch of stuff, and it was really, I mean, that's what I would do. I would just get a camera and go out and shoot things, and then I'd look at them and listen to the music and find little elements. And then what I couldn't put as a real video reference, I would put as I would get into 3D Studio Max and I would model something and I would animate it. And it was really simple back then. It wasn't like I had to like come up with all this crazy stuff and have 5 animators. And it did get to that point at one stage, but it started very small, is the point. And it really gave me kind of a safe place that I could work and try and experiment with these different looks and different ways of producing media content for musical type shows. And I really enjoyed it. So I really loved working for these people. That was Asia 43, and this was my first show with them. Incidentally, it took off, and they did it, I think it was Light and Sound did a big article on this show and used it as a cover, this particular photo over here. And it got a lot of recognition, so they saw that and they thought it would be a good time to like invest in doing a bigger show. So our next show was Asia 44, which was in Kodak Theater, and that was a big show. Same kind of sort of format with the screens, but different set. Again, this set was designed by John Calkins, but I did all the lighting. Yep, that was projection, all projection at that stage. They thought the projection, they liked back then, a really high-res, dense projection was hard to come by. It cost a lot to rent. Like a 3mm screen was absolutely astronomical in terms of rental price. And the lower res was like 10mm or something, like affordable LED was like 10mm. 7mm was just on the edge back then. And so the projection was a good alternative to go to because it provided a high-res screen that in television, when you have it as a background, it didn't look all pixelated. So they got used to that. But the disadvantage is that we needed so much space behind the screens to get the throw. Yeah, it was rear projection. In television, we can't have front projection because it spills all over the key light, which you have to keep segregated completely, otherwise you get that contamination. So there was always this, okay, how many feet downstage from the upstage wall do we have? Okay, it limited our choice of theaters, limited the depth of the set. A lot of things were limited as a result of that. So we did a lot of projection on double or triple stacked each screen, really bright, punchy projections, and they provided a nice canvas. In this show, I was really getting a lot more into After Effects by this point, and compositing, using all all of my content feeds that I had and all the different various films that I took, as well as 3D Max stuff. I was still heavily into 3D Max at this stage, but I had a lot of time at this stage to play with that stuff, and so I did. I learned After Effects like from the very beginning. I went through all the all the tutorials. I went to all the NABs. I did everything I could to learn all of this software so that I could leverage the power of it, make my life a lot easier when people were asking for stuff. Because people inevitably at this stage, they see that you can flip through video and they walk up, hey, and they're like, hey, can you do this? Can you have this? Can you? And you want to accommodate them as best as you can, especially if it's the producer or an artist asking you for something. So yeah, I mean, I spent a lot of my off time in just learning. That's all I would do, is I just sit in bed or at my desk or whatever, wherever I was when I was off. I was constantly learning stuff, playing with software, learning what the new stuff was. I'd go to all these conventions and figure out what was the new thing to make content. And how could I utilize it in what I'm doing with this? I literally got tossed into this. It was because I played with the Catalyst on a show one time, and everybody thought it was cool. So I got tossed into like doing these huge shows where I'm having to provide all this content, and I was able to do it with my camera and then 3D Max, but kind of to a limited degree. At first, and slowly I got better and better. I just kept with it. I kept learning the visual side of things, and eventually I ended up doing a lot of shows for Univision. And this is one of the shows. Premio La Nuestra was back in '03, the first show, as you remember, that I did use the servers on, and this was sort of a graduation from that. And it got bigger and bigger. And what used to be one server turned to 3, turned to 6, turned to 12, and it just kept growing exponentially, universe after universe. And then back then we didn't have, ArtNet-based consoles that you could have like 40 universes off of. We had like the Hog, and we had overdrive boxes, and we might be able to get, 8 universes off of one console if you did it right. So I'd have to have 2 or 3 consoles set up, because I was not only doing just the visuals, I was also doing the lighting, because everybody thought, oh, hey, we can save money and have one guy do it. And so I was able to do it for a while, but it was hard. It was really hard work. It burned me out. I mean, to be honest, it really did burn me out. And the next show after this was the Latin Grammys. And this was I think the first one in Mandalay Bay that they did. The whole set was nothing but video. Everything in the set. I had, I think, 21 outputs. So it had gone then from like a dozen to 21. And it just got crazy. It was nuts, but I thoroughly enjoyed doing it. It was risky the way we were doing it. Now that I think of it, it was very risky. We didn't have a lot of backup sources and stuff like that. And occasionally screens would start stuttering. Little things would happen as a result. But this was the visuals part of my journey. And I learned a lot from that in terms of drawing, in terms of doing 3D and graphics and all sorts of stuff like that. Well, at this stage, I was totally toast. So I took some time off. I went to New Zealand, and I relaxed for a bit. And then I came back, and I was doing shows still for a few people, namely the Asia people that I told you about before. And they had a couple new studios by this stage that they needed some sets built for. So I thought, well, this might be a good, kind of a fun thing to learn, since I'd already been drawing sets. So in 2008, I did my first sort of CNC-based scenery. And I took a bunch of time to build this set and experiment with CNC. I was really inspired by what I was seeing happening in terms of algorithmic design online, and I liked the look of it, and but I was only really working in Vectorworks by this point. And I designed this whole thing in Vectorworks, which was a task in itself. But it was interesting because you know, I was able to get each one of these. Oh, did I just? Okay. I was able to get each one of these little rib parts here extracted out of Vectorworks and laid out and nested and sent it to a CNC shop. At this stage, I wasn't doing my own CNC. And I sat there and I watched them cut it out, and then I did this little lamp thing, which is also based off of CNC, all just standard, you know, flat parts that you could put together like a little model. And I thought it was really interesting how all of that worked, that you could create something in CAD and send it digitally to a robot that would then cut it out. I mean, I thought that was incredible. It's a really cool concept that you can do this sort of thing and do it at a speed, you know, at a pace. And so, you know, it's not terribly impressive set or anything. It's quite modest, but it was a catalyst for something. And I think, you know, with these things in life, you eventually realize that small things can mean really big things later on. So this was sort of the catalyst for the whole scenery side of things, of emergent entertainment. And I was able to really play with this set, and I had time. It wasn't like a hard deadline or anything like that. I had time to kind of experiment and draw things the right way and figure out a system, etc. After this, I did several of those Asia DVDs, but I still wasn't doing the set. I was just doing lighting, but they were kind of, you know, putting it into my head that, you know, maybe I should be doing the set as well as the lighting in the video. So in 2012, I did just that with the very first full lighting video and scenery design that I did, and which was for them. And I was using quite a lot of algorithmic-based parametric modeling software to develop most of this. I drew the bases in Cinema 4D. By this stage, I was no longer using any kind of Windows-based like 3D Max or Autodesk software. I was using Cinema 4D and Rhino to build the set parts. And it was incredibly liberating to be able to do things parametrically. These are just some of the photos. We did all the video design, the entire set design, all the lighting design. It was a big success, this show. I think they couldn't really believe it that I pushed this out. I mean, all of this stuff was custom. And we got it sent to a fabricator who did a really great job, CHOVET. At this stage, I was not fabricating my own stuff yet, but I was thinking about it because I would do things like this, right? And off to the right, you see it's called a Ware-Fallon algorithm that was patterning these shells on the side, which were these shells here, off to the side here. And it's hard to see in some of these photos that I have here, but they're actually bubbles on the set. They're actually bubbles that are coming out of these parts. And this is another reason why you don't want just, if you can, you want to have a little bit of front lighting on your internally lit structures, because it's hard to see the plastic sometimes, the shimmer on the plastic that defines the shape, but these were actually bubbles that came out. And one of the things that CHOVET was trying to get me to do was to make all of my patterns kind of uniform across everything, rather than have a different pattern for every part. And I just thought that was weird, because what is it? What is it? Just like load up the file and recam it, you know, if you have a different pattern. But a lot of production fabrication warehouses were saying to me, if I was going to do something, try and keep it to like 1 or 2 patterns. And I thought that was insane. So I started researching how to build a CNC, and I'll get into it later, but I ended up building my own CNC as a result. The next show was Asia 70, which I did the same thing for. All the lighting, all the scenery. There were no video elements in the show, scaled back a little bit. And as you can see, there was quite a bit of CNC in this, and a lot of non-rectilinear surfaces. So we did a lot of, this was an interesting piece here. Those columns had two color force in the bottom, and they were basically just plexiglass that was printed on with a thermal dye sublimation printing. So you could do really huge prints on this plexiglass and then backlight it, and it ended up looking really good. So after this, I took another little break. I took these occasional hiatuses where I kind of just relax for a while, and I learn, do a lot of R&D. It's important to do because any kind of growth, it's really difficult to grow as an artist or as a designer if you're just working all the time. It really is. I mean, you get to see new things and you do new stuff, but it's hard to learn new technologies if you don't have the time to learn them. So during my break is when I built the CNC machine, the first CNC machine, and I built it in New Zealand. And it was, it took me quite a while to build it. I was just researching, and I was trying to figure out, all of this stuff. And eventually I got around to building it. And just as I finished, I had a call from a company in California called KVLA. They were building a new set of studios. So I went to Huntington Beach and got to talking with them about what we were going to do, and I realized it was going to take a lot of CNC work. And the amount of CNC work that I was going to put into it was kind of equal to if I had just built a machine anyways. And I really wanted one in the United States. So I ended up building another CNC machine. And that machine took 2 weeks to build. It wasn't very long at all. And as you can see, the set was quite inundated with a lot of CNC machining, and I didn't just stick with one pattern across the whole thing. I was able to do several different patterns, and I was also able to do very detailed work. So for instance, these little panels here, this is a great example of high detail work where each panel would take like 4 or 5 hours to mill. Because it's so, the corners are so tight that you have to remachine and using smaller bits to get tighter corners. The thing with CNC, unlike a laser jet water jet or laser, is that you're constrained to the radius of the bit that you're using to get as tight of an inside corner as you can. So any inside corners are always going to have a radius, a round part to them. So if you want tight corners, you have to use really small bits, but you can't use a tiny bit to do the whole thing, so you need to kind of gradually step down or remachine to that. So we started building the CNC machine, and this is sort of that process of building it. And these are laser cut bent parts that I would just go to a company in Orange County to get cut and bent. And then, this is the assembling of the machine down here, over here, and sort of almost final of the machine being ready to cut. And eventually getting to the point where we were able to push out stuff like this. And this was their little news studio that they did, but all this was entirely cut with that machine. And you can see kind of how it was built, and all the parts and that were. This is mostly plastics, and a lot of the structures that we do are basically. Here's a little PDF of one of the structures. That's one of those little arcs. It's basically a metal frame that's welded, and then the plastic that goes on the front of it. So we tend to CNC the jigs that the metal frames are put into, and that way the plastic will always fit. We found out that kind of the hard way, because sometimes if a welder gets it, it's not as perfectly precise and there's little gaps. So we try to do everything constrained to these types of jigs here, even simple things, because just even a 1/16 of an inch off, you know, it can waste a lot of plastic if you start cutting plastic to your drawings that you drew, and then the welds or whatever, the as-builts are not the same. And there's not a lot of time to go back through and redraw everything after it's been welded. So here's sort of a picture of our warehouse and kind of the process that we go through to make some of these sets. That's the desktop of that particular news set, and then over down in the corner is those are the little header pieces for that. Then these are the screen surrounds for the talk show set that was that we were developing. I've been kind of touching on algorithmic design, which is kind of what I'm trying to leverage as a technology to do complex shapes in very little time. So this is an example of one of those shapes. It's known as a Voronoi algorithm. And with a Voronoi algorithm, I can change the density of Voronois. I can change the radius on each end. I can do all sorts of changes, sweeping changes in just a few mouse clicks. And it completely reconfigures the Voronoi. And this is kind of where I'm heading with all of this, is I'm going to show you this technology and how it works. Okay, so then here are some of the panels that we designed, and the CNC cutting them. And as you can see, this is known as a de Lunai algorithm, triangulation. So it's sort of the opposite of a Voronoi, and yet with this one, I put a curve through it, and then I put an attraction on the curve that caused all the de Lunai triangles to be thicker framed near the curve, nearer to the curve. So you can do these really incredible things with thinking of your design as more of a mathematical program, in a similar way to how you would program moving lights, for instance, using references and attractors and effects, sine waves, things like that, right? So here's more of the machine cutting, staging and facades for the front of the staging. Here's kind of like when I go away from these things, I do a lot of research. So the machine still in New Zealand is where I tend to go. And so I kind of got into just like playing with smaller versions of the set in furniture that I was making, just kind of for myself and for, to try and learn new techniques of fabrication. It's something that you really need to do. You really need to experiment, play with stuff. It's really important that you don't just limit yourself to entertainment. You look in every aspect of how the fabrication process and designing stuff applies to. And one of my interests has been furniture. So when I'm relaxing and stuff, I'll still work, but kind of to a fun way, and this is fun for me, is still playing with the CNC, but using it for other stuff other than entertainment design, but stuff that I could apply it to, and I learn a lot in the process. So like with this, for instance, this was just a little mirror. It was like a mirror frame, but it was a really complex geometrical mirror frame, and it took a lot to figure out how to make it. And it was basically MDF, a double stack of MDF, and a 2D cut on the outside, a 2D cut on the inside, and then taking that and just, you can see here, using a ball mill, just milling the whole shape out. So it's all 3D milling. With CNC machines, generally they're 3-axis. You can use the Z-axis extensively to create these 3D shapes. And from there, you know, a lot of people will use those in fiberglass to create molds for fiberglass, all sorts of things. Vacuform, that's a huge part of entertainment design, vacuform. So the thing with vacuform is you really need to have a 3D mold to use in order to create the plastic vacuform molds that you vacuum to that 3D. And this is how you do that. You use ball mills and MDF and plywood to create dimensionality in your vacuforms. So this is just another little table design. As you can see, it was cut on a CNC. And from this, I learned a lot about joinery, how to join different types of woods to each other, the tightest ways to join, the most seamless ways to join. And it's really, it's quite useful to be able to you know, have some experience in this. Okay, so that brings us to today. What are we doing today? This is this current set that I'm working on, and that I've designed, and Martha and I and the rest of the crew are cutting and getting ready to install. So this is the new, thank you. It's a new set and sort of a news talk show set. I designed most of it in Modo, and then a lot of the patterning and stuff I do in Rhino. And then we take it as a full mesh from Modo into Rhino. And then we pull all of the curves off of it, and we create NURBS surfaces, things that we can utilize in CAM. So it's quite an interesting set because it's got so many off angles on it. There's a 45-degree angle going this way, but all the rest of the angles are like 54 degrees or, you know, really odd angles, 42 degrees. I wanted to use this as sort of a backlighting element, you know? So that's at around, I think it's like 34 degrees, something like that. So it can reach the people that are sitting at the desk. There was a lot of engineering on this desk that I had to do just to figure out how to make it look so seamless. You know, this part in particular that leads up to the desktop. But it's really just a frame inside of this thing. And most of these structures we do are typically a metal frame with plastic on it somehow. So here's a picture of Martha doing some CNC work. Right now we're cutting the sides, which are right here, these bits. And this is kind of an interesting thing because we wanted the sides to stay intact, and we wanted them to be all one piece but folded. So I'm using this material. It's called polyalume. And polyalume is interesting because it's two pieces of aluminum that are sandwiched, that sandwich a PVC core. And it's colored or white or even brushed metal aluminum. And with that, you're able to do some really cool folding things. You can make boxes out of this stuff by using a V-groove as your tool. And a V-groove is basically like a V. It cuts a V down in a line, but if you grind the end off the V, you can cut a groove that doesn't go all the way to the bottom. And with this stuff, since it's aluminum backing and aluminum front, you can fold it and you can make some really interesting shapes. And I believe I have a video where I kind of explain this. Oh, let me go back here. Let me just find my mouse. Oh, here we go. Okay, so let's go back here. Oh. Okay.
Here is we're doing what's called V-groove operation. And what V-groove does is it utilizes a bit known as a V-bit. I'll show you one of them. This would be a V-bit. And as you can see, they call it a V-bit because the end, if you turn it this way, looks like a V. You guys see that? So what we're doing here is we're using a larger V-bit that has a 90-degree angle to cut a groove in a curve in there. This groove will act as a bendable area that we can close at a right angle. And we can put glue in there and it'll hold its shape at a 90-degree right angle. So right now we're doing the top side, which is black. All of these will fold concave, and when we flip it over, we're going to do the other side, which will be the convex side. So we always have to make sure we get it exactly in the right place when we flip it over. And that's improving. We're going to end up with something like...
It's all the way back there.
Oh, we're going to end up with something like... This will be a sort of a light box that will have acrylic on the inside here, and we'll put LED in each one of these holes and mount it to the side of a news desk. That's how you get really cool shapes like this. We could have, of course, put it together piece by piece, but I think that would have been a little bit more less efficient and more time consuming. And for the result, this is flawless. It looks like a spacecraft intake valve, something like that. So there you have our cool little aluminum core trick. It's like an accordion.
So this stuff is really cool because once you develop the algorithm to bend it in certain ways, you're able to apply that same algorithm, the same cutting to every other type of situation that you encounter that's like this. And then it becomes very quick. You spend a little bit of time doing the first one, you use those same cutting techniques for all the rest of them. And you're able to make, all sorts of folding parts and pieces that would otherwise mean, taking each individual part of that box, creating, each part individually and gluing it all together. And that can take a lot more time in the long run. So if you take a little bit more time in the beginning to design something, a system similar to that, it's really going to pay off in the long run. And that's where a lot of these algorithms that I'm working with come into play. And they also, it's a little bit of initial time creating the algorithm, but once you create it, you can use it for everything. And it's well worth the initial time that you spend. This is Martha working with the CNC. The CNC is much like a moving light. And I think that's what resonated a lot about it with me. It was that it has it has 4 stepper motors, 2 for the x-axis. It's got an x-axis, y-axis, a z-axis, and you have to home it. You have to calibrate it, and you have to home it. So it uses the same sort of technology. It's drivers that drive the CNC, driven by a computer. The computer has, you program it just similarly. You draw something, and then it tells it where to go, X, Y, and Z. But you have to line up a corner first. And we have a couple ways we line up corners. We have a laser. We also have a probe that we use. But sometimes we like to get very precise and make sure that the tool is right on the corner so that we can always repeat if it happens to go out of calibration, which it tends to do from time to time. At this stage, I would like to go into a little bit of Q&A, and then I'm going to go into some of the algorithms and the technology behind some of what we're doing. So if any of you guys have any questions. Yeah?
The software you were just talking about, Modo?
Yeah.
Could you explain a little more about that? Is that a Mac software?
It's available on Mac, Linux, and Windows. Modo, let me see if I can show it to you here. Okay. Just give you a little demo real quick. So Modo is a mesh editing software. Unlike most NURBS editing software, it's entirely mesh editing. And it also does subdivision surfaces. Oh, hold on a second. Let me just bring this over to that monitor. So this is the Modo interface. And if I'll try loading. Let me just get it. Let me just get it loaded with a hold on, sorry. It's a bit awkward going from that one. Hold on, let me bring it over to this side and load it up with something first so I can kind of show you what it's about. But yeah, basically it's just it's a mesh editor, but it's an interesting mesh editor in that it edits, the way you're able to edit your meshes, you can use dimensions like inches. So a lot of architects are using it, a lot of scenic designers are using it because you can bring it into Rhino and all your divisions are like an inch apart or however you've specified, which for a mesh editor is quite phenomenal, I think. Most of the mesh editors that are out these days do somewhat of something similar, but you don't have as much control over it. But this is Modo here, and oh, here we go. And this is here's one of the set files that I'm using. Let's just see here. Let me just get this out of full screen. Huh. Okay, well, something has happened. Let's see. But yeah, that's kind of what I use as an alternative to what a lot of designers are using SketchUp for.
So is this like this would be a component then in the design? This isn't, you wouldn't do the full design in there, or would you do?
Well, for what I typically do to start is I'll do a pre-deposit, just a rough rendering, like just all visualized stuff, pre-conceptualized stuff that I can render out real quickly and send to the producers. And the producers, if they like it, they say make up a budget, and if they don't, they say something else, do this, make these, and it's really quick to make alterations in. But I don't do a lot of really extensive fabrication engineering or CAM work in it or anything like that. So it all starts off as that step, just to come up with some kind of visual, some kind of production design that, it's just basic shapes. Like all this was done in Modo to start off with, this whole rendering process. It's just very quick. And I either used one of two tools, Modo or Cinema 4D for that. Cinema 4D is kind of nice because you can use the MoGraph module, which is mainly for motion graphics, but you can use it to create really quick things like stairs and stepping things and like repeatability. That's like the big part of the design. You create one component and you repeat it throughout your design. It makes it really look big, but with minimal output in terms of energy. So it's an efficient way to work. And both softwares have a cloner type of tool in it that you can clone your parts from. But Modo, it's just, it's very flexible. It allows you to like bend things around other things. It's very, I like it a lot, Modo. But all of this was designed in Modo as the front end package that I would design just to create renderings for the producer. And then once that's all approved, I take all of that into Rhino and I break it apart and get all the curves off of it. And yeah, it kind of gets a lot more detailed at that point. Anyone else? Yeah, Joe?
So you mentioned before you like to internally like scenic elements, but you front light them to get detail.
Yep. Yeah.
When it's on a broadcast set, how do you avoid spillage?
Well, that's a good question. The reason, a part of the big reason why I internally light the scenic pieces on a cam shoot, on any kind of production that's being filmed or shot, is because the front light, it just destroys the close-up. So you really have to be very careful about that. You really have to be very careful about contaminating the close-up with blue light or dark blue Congo, whatever type of light, because it just blows it out. And if you're really pure on your close-ups, you want to be able to turn out the light and it look completely black on the person's face. Okay, so that's like the rule number one. Anything that's downstage of the performer, you have to be very careful of how you front light it, because it will spill back, and even if it's not that in line with the performer, it can bounce off the floor. The floors are typically shiny on all of these events, so they just bounce off the floor and they go right into the performer's face, and you have to be very careful of those types of situations. So I'll generally try to front light some of the stuff upstage, Joe, and the stuff that's internally lit, just to give it a little bit of front edge. And then stuff that's downstage or in the way of the performer, I try to avoid that entirely. Or light it when the performer is not there, and then take it out when they go into that area, which is a little fiddly, but sometimes you have to do that. Anything else?
Can you talk about your theories of color temperature for broadcast lighting?
Oh, okay. Well, everything's based around the close-up. Everything. The look of your entire show is based around the close-up color temperature. So if you're keying at 3200 Kelvin on your close-up, that means you're going to correct all of your front lights to 3200 Kelvin. But that also means all of your entire rest of your show is going to look extremely blue. So you have to be very careful, like, if you're using a lot of blues, even if you're using magenta, your magentas need to be warmer magentas, or your lavenders need to have a bit more warmth in them if you want to key at tungsten. That's 3200 Kelvin. Now the trend has kind of gone upward with the sensors on the cameras in terms of color temperature. So people started keying at 42, then 48, now 56. And the higher you go, now your show's going to start looking a little bit warmer and redder, and your blues aren't going to be as blue. So that's kind of the give and take of it. 5600 Kelvin, it can look great if you have some really blue fixtures, a lot of really saturated LED, stuff that casts really blue. I tend to try and sit at around 44 to 48, depending on the type of CCU that we have, because a lot of CCU can only do two color temperatures, 3200, 5600. Okay, so then you're stuck with that, and they can't. It takes a really good CCU guy to be able to take the blues and the reds, look at the scopes properly to make it whatever color temperature you're setting, 4800, 4400. So you have to know your CCU guy, and if it's that was the reason why for a long time I just said 3200, leave it at that, and we'll just deal with it, because 3200 at least makes all of the white light look a slight blue. So your backlights look blue. They look like moonlight, and that's kind of a nice look to have, yet you're going to always get a really beautiful close-up with that. So it really depends on the situation. It depends on the production. It depends on how many tungsten fixtures are in the production versus arc light or LED. There's a lot of variables that help me decide eventually what I'm going to key it to. But it's something that, a lot of people don't understand, that your key light is responsible for the entire look of your show. So you got to choose carefully when it comes to that.
Will you adjust the lights for your show based on the color temperature of your key lights then?
Coloring, color palettes generally are a little bit adjusted if it's 3200. Like I was saying, the lavenders tend to look blue on camera, and almost all the magenta lavender range of color tends to start looking tinted blue. So you don't want to end up with, and I'm sure a lot of you have seen this when you're watching television, the show looks blue almost all the way through. So you want to be careful about that. So you want to try and have some warm colors, warm color acts. And I try and offset, if I'm corrected to 3200 Kelvin, I'll try and offset each blue look with a warm look, and then maybe a pink look, but it's really in the range. The only change that you need to worry about keying from 3200 to 4800 are just be wary about your lavenders, your magentas, your kind of your roses, that range of color. Because if you tint it a little bit warmer, like a Guccione-like pink, if you tint it sort of like that rather than a pure lavender, you're going to get a lavender look on camera. It won't look like that to the naked eye, but the only important part of a broadcast is the camera. I mean, you have a small studio audience, and you have a very large television audience watching it, so you have to cater for the larger, the majority in that case. Yeah. Anyone else? Okay, so I'm gonna just quickly kind of show you a little bit about the parametric design process, and I'll go over a couple of the set pieces that that we've used in some of the slides that I've showed you. If I can. Just have to launch this, so bear with me. Okay, now let's see if I can mirror it so that I don't have to have it on the same. Let me just mirror the display. If you guys need drinks or anything like that, you know, feel free. It's fairly impromptu at this stage. So, displays, show mirroring options, arrangement, mirror. Okay. All right. So now we're mirrored, and now this should be a lot easier. Okay. So I use a Mac, but I do a lot of PC stuff on my Mac. Most design software, any kind of heavy-duty design, industrial design software, none of it is made for Mac. Very, very little of it is made, actually has a Mac type of interface on it. So the first thing I'm going to show you, here's Rhino. This is the Rhino interface. The reason why I have it as a half screen right now is because there's another component to Rhino that I use called Grasshopper. Grasshopper is the algorithmic modeling aspect of Rhino. Grasshopper has a lot of power. It's basically everything in Rhino under the hood wired in a different way. And and I'll show it to you in just a second. First I'm going to go ahead and load one of these files here for you. Header base splines. Okay, so just get my little 3D mouse working. There's one of these. Going to Windows. Just bear with me here, guys. I think that one's it, right? Windows. Okay, all right, so we have our 3D mouse. Okay, so we have our 3D mouse. Okay, I believe this is the file, but it doesn't look like it's the same file, so let me open it up again. Oh, I know why. Stuff is hidden. Okay, so this is the header design that that I showed you, or at least part of it. I futzed with one of the header pieces in Rhino, and this is kind of what it bakes out as. But this is not how I design. I don't just start drawing like this in Rhino. There's a very different process to all of this, and I'm going to kind of go through that with you. So I got into all the furniture stuff. I got into doing all the algorithmic stuff in the very beginning, but you know, I kept hearing about this program called Grasshopper, which is this plugin to Rhino. And this program, it's really interesting because it's very much like Houdini. If you guys are familiar with 3D software, Houdini's or Shake is like a node-based type of 3D software. Node-based meaning you create everything with nodes. It's a nodal-based type of software, and you can rearrange the nodes to suit different options, and you can have like 10 different options by plugging in things slightly differently, and it's very flexible. So I'm going to show you how I arrived to this. Is we use Grasshopper, which is the plugin to Rhino. Starts off like this, and what it does is it rearranges all of the commands in Rhino in a very editable parametric manner, similar to like when you're drawing a square or rectangle in Vectorworks, and you're able to change the width and the height of the square. It's very similar to that, except you have a lot more flexibility even than that. So that header, we'll go ahead and open up the definition for the header.
Can I ask a question?
Yeah, sure.
What do you mean by parametric design?
Parametric design means that instead of designing with straight lines and that are not editable after the fact, you're designing with lines that have a parameter associated with them. For instance, the length of the line. So with that said, you're able to take the length parameter and readjust it after you've drawn the line by saying 12 meters instead of 6 meters. And the line readjusts. Now, if you base everything off of parameters, you can say divide the line by 6 inches or whatever, and have little points, and then from those points have another line that's perpendicular to that line by 3 inches. And you can take all of those parameters and line them up and start adjusting those parameters and make sweeping changes across your design in very little time. So here's the whole header designed parametrically. So almost any aspect of the header now I can change. Okay, I can change, and this is how I found a lot of the intersections that were happening in the header. So this header is the same header that was in the Asia 69 show. And I'm going to go ahead and show you what I mean by parametric. And I'm going to kind of zoom out on the definition. Okay, so you can see basically what is involved, what's entailed in this. So the whole definition is over here on the left side. Okay, each one of these nodes here represents some aspect of that particular element. Okay, the top part is the stage left part. The bottom part is the stage right part of the header, which is over here. Okay, so stage right, stage left. Okay, so if we look over at the stage left piece here, I'll just kind of zoom up on it. And what I'll typically do is I'll put all of the parameters that I can edit over to my left side here, which is all of these line up. Okay, and from here I can do some pretty interesting movements, like I can move the top back a little bit. Okay, so we can really start adapting the look of the header. And this entire thing is just built off of 2 curves, a top curve and a bottom curve. So we could recurve it if we wanted to. Now I'm looking at the different sails. Okay, so this is the top stage left sail where it's intersecting along the curve. So I'm able to sweep that over to the left a little or over to the right and slightly reconfigure it. Now, the reason why I started doing this was because I wasn't sure exactly how much space I had in certain areas to put this thing. But I wanted a design that was flexible, something that I could sort of reconfigure. So I started building it like this, and then I realized that, oh, well, the header pieces, the sails, the individual sails on the header, they are intersecting in each other, and I need to figure out a way I can physically see exactly how these pieces are going to intersect each other, so that I didn't have any self-intersections of fabric, because it's impossible to build something like that that's going through another piece of fabric. So, but I wanted to take it to the very bleeding edge of intersection. You know, I wanted it to look very dimensional, and the only way I could do that was just to sort of pre-visualize it. So, you know, play with things. And as you can see, by intersections, I mean things like this area. Okay, so if I zoom up on here, you can see this sail is intersecting down into this other sail, the large sail. So to get rid of that, you know, I would have to go and I'd have to find that sail, the second sail, and I'd have to change the whatever subdivisions on the piece. And and find the areas on the pipe that would not intersect with the corners of the sail. And that's why I ended up starting to build this definition to begin with. So as you can see, as I'm moving these corners of each sail, they're intersecting. But there's parts that they're coming out in front of, but they're still not intersecting, like right there. So if we look up on this part now, it's slightly intersecting, but we can futz with it, with the design later on. But to get this kind of editability, it takes time. It takes time to generate the algorithms to be able to further edit this system. And, but like I said before, I did this. It took me maybe a couple days to build the algorithm. But now I can use this for any show, for any set of curves. It doesn't need to be this particular set of curves that I'm using it for. I could draw 2 more curves right now and just say, you know, we'll use those ones instead. So right now it's using this top one and that top one. But they don't even need to be, I believe on this one, they don't even need to be on top of each other. We could just go top. And we can just play here. We can just use a curve like this. For instance, we want to build a new sail type of shape here. And now I just go over to my algorithm here, if I can get it to zoom out. And we'll change, let me just grab this curve here. We'll copy it. We'll copy it in place. Okay, and then we'll edit that particular curve to be slightly offset from the other by just grabbing this line here and, sorry, this point here, And now we've got 2 curves that are on top of each other, but they're slightly opposing, right? So all I now have to do is enter those 2 curves into the algorithm instead of these curves that are set currently. And I'll go ahead and do that. So we'll take this curve.
So when you said earlier, it takes you a little while to build the algorithm, you're referring to the thing on the left?
Yeah, the definition. Exactly. That's
like the algorithm.
Yeah. So
That from scratch and then
exactly.
the formula then later apply to
Anything else that I use it on. Exactly.
Modules that are coming off.
Exactly. So now you can see this is the new set, right? But I still have all the sails. I still have all of the functionality that I built in the algorithm. All I had to do is build 2 new curves. Now, if you think about the power of this, right? Think of something you build a lot of, like columns. Everyone uses columns in their design, right? Columns can have 10 rungs. They can have 5 rungs, 2 rungs, 3 rungs, whatever. They can have vertical rungs. Well, you could create an algorithm based off of 1 line, that being your column. So you create 1 line, 120-inch line, and then pop it into your algorithm, much like this sail, and it'll populate it with whatever parameters you decide for it. And then after the fact, now say we like this, which we don't actually like it, but just for the sake of time and argument, say we like this, and we want to bake it out. So at this point, I have the ability to bake out all of the sails. I've got the ability to bake out, so we'll go ahead and do just that, if I can find the bake points. And this will bake it out into actual geometry. Okay, so we'll go ahead and see where I'm trying to remember where the bakes are, but it goes from, at this point, it goes from, you know, algorithm to hard geometry in the software itself, geometry which you can further. So here's what it's baked. All these curves here are the pipes, and then the sails. Let's just bake them out. So I end up going through and individually just going through and baking out all of the geometry that I have ended up with from the algorithm. And once you do that, you can take all of that and flatten out, get it ready for CAM. And and then it's good to go. So here's the large spandex sail. So yeah, the more time you craft these algorithms and you build up a library of them, the quicker you can spit this stuff out.
Let's go to something.
Yeah, so anyways, now if I go ahead and close that, I'm left with the shaded version of, you know, what I ended up just baking out just then. But that's kind of the general principle of what I've been working with and how I got there. And thank you guys for, if anyone else has any questions, I'm happy to wrap it up here and take them. Does anyone else have any questions? All right, well.
Right now, you've got a unique perspective, and there's lighting designers here. And you're a scenic designer too. So many of the guests are not scenic designers. So what advice would you give them as a lighting designer to get along with someone who's just a scenic designer?
Collaborate with scenic designers, yeah, or become a scenic designer?
Collaborate with yourself.
Yeah.
But like what if there's two people, one's scenic, one's lighting, what
well,
does a scenic designer expect from a lighting designer?
A lot of the times I think it's interesting collaboration, scenic designer and lighting designer. The scenic designer will leave a lot to the lighting designer because of trust and reputation and things like that, and not wanting to micromanage, things like that. So I think as a lighting designer, you really need to understand how sets are built, and you know, treat it as if you built the set yourself, and you should have no problem, really. Treat it as if you've built the set yourself. Lighting it is, you got to look at every detail of the set. It's easy to overlook the front section. Don't just look at plan everything, you know, which is overhead view. When you're doing light plots and things, look at the front section, look at the side elevations, you know. Really look at the set in 3D and see how you can light each aspect of it the way it should be lit, detail-wise. And you should have no problem. It's not always a simple matter of just throwing wash lights on the front of a set. Oftentimes it's what kind of LED tape you're going to use, in what spaces, how much space you have to put what fixture. You know, E-picks, if you can stick some of those vertically, or you know, inside a set in certain channels. You need to find all those little things, because the set designer doesn't always have complete control over all the practicals within a set. It's often the lighting designer that they trust to do that. So if you're presented with a big set, break it down, look at every aspect of it, see where you can put light. Put light everywhere in the set, and you should have no problems, you know.
Do you have any thoughts on a different configuration of wash lights that you would use on a set, like, you know, bar style, batten, cube, panel?
You mean front wash?
Yeah.
Yeah. I think that some of the stuff I've seen here at CHAUVET, the Rogue line and the Maverick line, that's the sort of type of fixtures that I would typically use on the front of a set, you know, to wash them. Something that zooms out and you can really flood well and has a real punchy color mixing system, something robust in terms of color. Also, it can be fun to play with texture on set, especially you know, some of the hard edge fixtures. If you're able to defocus them, get them spinning gobo-wise, counter-oppose the gobo rotation, get some watery looks on the set. That always plays really big. Get the watery look kind of, you know, going on the set along with the wash. But I mean, there's a lot you can do with both wash and hard edge fixtures on a set. You can even use like the edge of a triangle just to light up a small aspect of it. You can use a lot of times I'll use a single, like a laser line gobo, just to get like that edge right there. You know, if I don't have a bunch of shuttering profile fixtures, I'll just use little aerial gobo slots parts and profile them off and spin them in such a way that, you know, they light that aspect of the set. On camera, it's important when you're looking at the background. You know, when you're looking at what's behind the performer that you're lighting, you've got to really meticulously light the scenic behind them, bring it out and make it pop. So sometimes, you know, you have to use like the edge of a gobo just to get this little tiny part. But there's a lot of there are a lot of tools in a lot of these lights that we tend to overlook. Don't overlook them. See what you can do with every kind of gobo. You know, every kind of light. Don't just think wash lights. Think, oh, can I hit that part with you know, hard edge in some way, some manner, and it'll pay off big. Usually it does. Anything else?
A lot of questions, but how important do you think it is, sort of when you're presenting a show to either a producer or to, you know, potential clients? What do you think they like to see? What do you typically show them, you know, to give them the idea? Would that be something like your mortar drawings, or do you do something that's, you know, do you ever do hand-drawn things? What type of things do you use to kind of convey the general idea, or the, you know?
Yeah, usually I'll use a full rendering to do it. If I don't have a lot of time, and if it's something that I'm not positive about what type of materials I'm using on those parts, I'll do just the ambient occlusion rendering, which is pretty much black and white, but it looks very shaded. You know, they get a good idea of what the structures are going to look like, but they don't know what the texture, what type of material, whether it's metal, whether it's plastic, glass, whatever. They don't have that idea. So, and in some ways, a little bit of ambiguity can open up their vision a little bit more. You know, sometimes you don't want to go all full detail on your renderings, on your first renderings that you're doing. It's good to be, and oftentimes what I'll do is I'll render out a sketch tune. So I'll use a sketch tune render style, and where it looks sort of like a drawing or a sketch, almost like a cartoon in a way, you know, but there's several different styles. Like even in Vectorworks, and most of you probably use Vectorworks for your drawing. In Vectorworks, there's a huge sketch tune styles library in your renders, in your RenderWorks package. And there are a lot of different options for, you know, pushing out renderings that look like sketches. So you can start working with geometry instantly and render it out as if you sketched it out without much detail in the color, with a lot more ambiguity in the texture, and still give a great idea of what the set's going to look like. And you can push those out relatively quickly in comparison to texturing everything, making sure all your UV maps are right, and, you know, getting all your settings right. That can take a lot of time. If you have the time, you know, and you really want to make a big impact, you already have worked with this producer quite a bit, you know what they like, you really want to just get the budget really quickly, you can do a full rendering, you know, if you have the time. But if it's something quick, it's always advisable to go with less detail first, then fill in the gaps on the next meeting, you know, when you've kind of secured the contract a little bit. Yeah, you don't want to spend too much of your own money on something that's not going to, because it is your own time, it's your own money, it's your own effort that you're putting into it at the beginning until you get the contract. Yeah. Yeah. But yeah, I mean, you know, there's been times where I've done these huge renderings, and it was just like to provide a secondary option, you know, which they weren't really even considering in the first place. They just wanted. So I went out of my own pocket and did my own, you know, with my own time, you know, because you're just banking on it. You're banking on the fact you're going to get the contract. And sometimes you don't know who these people are. They're just calling you out of the blue, and you're like, oh, yeah, sure, well, let's do this thing, and, you know, we'll render up something. And you spend all this time don't spend the time with somebody that you don't know or haven't worked with before. Just sketch something out, even if it is by hand, like what you were saying. You know, a lot of designers, they just sketch something out, send it off. Takes them maybe, you know, 30 minutes. And I was actually watching this this guy who does concept sketches, and he was advising, you know, like if you can do 100 sketches in 100 days, you know, that kind of thing. It makes it so much easier to just come up with stuff really quickly. So if you're going to be doing this kind of thing, it's a good idea to know how to hand draw, or at the very least know how to model quickly, and then render out sketch-looking drawings. You know, because yeah, you can waste a lot of time in the wrong area. But yeah, anyone else? Any last? Yeah.
What do you use to render? What is it? Not RenderWorks. You're using Cinema 4D.
I use two renderers. I use Cinema 4D's renderer. I was getting into Arnold for Cinema 4D, but it's not quite there yet. but it's one of the best renderers out there, Arnold. It's just that it doesn't take the Cinema 4D parametric texturing, you know, the textures in Cinema 4D that you can readapt, and there's all this. It doesn't take those, so I'll avoid them for now. But until they bring that into that plugin, I'll probably avoid them. But the other renderer is the Moto renderer, which is what I did.
Okay.
Which is what I did this with, and it's an extensive renderer too. I'd say it's along the lines of Arnold, the Moto renderer, and it does some really unique things like neon. So you can draw lines and render it out as neon tube, which is great because you know you don't have to then render a tube and put a texture on it and all this other stuff. But yeah, presentation renderings. That's a whole that could be a whole another seminar. Presentation renderings, really, there's a lot to it, and one of the things that I like, one of the things that I consider with all of the software that I use is how well each of those softwares plays with each other, because invariably, once you get to the point where, yeah, you got the contract, you got the deposit, you're going to be pushing out all that geometry to a package that you're going to use for engineering, you know, or someone else is going to be using for engineering. It may not be you guys at whatever stage until you get to fabricating your own stuff, but you can save a lot of money. You can save a lot of money if you know a little bit of engineering and you're just doing small stuff where you can send out this file to a CNC guy and this file to a welding guy. Then take those things and put them together yourself. If you have the time or you have the resources to do that, you want to save money, and you're on a low budget type of event, then it's advisable. But it's even just advisable just to know how to do it, just to learn. You know, keep learning, keep growing. Try to learn all of the stuff so that you know how to do it when it's important that you do it. You know, so it's good. As a designer, you should know all of these processes, really, all the fabrication techniques. You should know how stuff is made in the shop so that you can design around that instead of do stuff that's just going to take a lot more money because you've designed it too tall or past 10 feet or whatever the constraint is for tubing, like 20-foot tubing, 120-inch plastic by 48-inch. I mean, you have to think of these things, because if you're doing massive windows, there's going to be a point where, okay, you've got a specialty item. That specialty item is going to cost a lot more than if you just did a division here, where everything was constrained with a 4x8 area. There's all these little things that you need to know, how things are broken down. And if you know them, you're going to save yourself a lot of money. Now, if money's no object, which in a lot of cases it isn't, then by all means design. Well, yeah, I mean, nowadays it's kind of few and far between. Pre-2008, nobody needed to worry about that kind of thing. It was like, what? You want to save money like building the set? Are you crazy? Just draw it and build it. Like it was that kind of, and now it's like, whoa, can we save a few dollars here? Can we save a few dollars there? Like whoever saves the most money, that's the guy. Let's go with him, so it's advisable to know how to draw efficiently for fabrication. Even if you're just doing drawings for your design, draw it in such a way, dimension-wise, that that your windows are going to be fit within a 4x8 piece of plastic. If it's nested, after all your cam is nested, yeah, okay, this column, it's only going to take one sheet of plastic. But if you have one window that goes over that one sheet, then you have to take a whole nother sheet of plastic for just one little window, and you aren't going to get the remnant to take home, No fabrication shop's going to say, hey, we had all this leftover stuff for you. So design with efficiency in materials in mind, and you'll do well.
One other thing, a lot of the people here do a lot of video panels.
Oh, yeah.
What would you advise if you make a big scenic element like that?
Oh, yeah.
How to incorporate video panels into it, number one, and number two is, if I have a big video panel array, how do I create it to be more than just showing, displaying images, breakout images, but to create a scene on video panels? Would be general.
Well, this is kind of a common thing that's been happening lately, is that scenic is kind of getting left out of the loop on a lot of stuff. Like there is no scenic, it's just video and lighting. The extent of scenic are the risers. Like that's it. maybe the floor, you know, if you get someone who knows a little bit about flooring.
You can get a backdrop.
Yeah, you can rent some backdrops, sure, exactly, some curtains and soft goods. So with that said, you can do a lot with just a little bit of scenery, you know, for your video designs that you guys are doing, full production designs for it, and you're really just doing video and lighting, add a screen surround. I mean, that's like a real simple thing. Make a screen surround, design it. Yeah. I mean, yeah, exactly. It's just something that goes in front of the screen that surrounds it in a kind of an elegant, cool manner. I mean, it doesn't take much, and you'd be surprised at how much dimension and depth that adds, especially if it's like, you know, a backlit screen surround, something backlit that has, you know, some plexiglass and little division and that kind of stuff, especially on camera, it plays really big. It really does. And it doesn't take that much to build. It's cheap, you know. I mean, you guys, you could probably pop a screen surround out for next to nothing, you know, if you did it right. Even if you had to just rent some atomic panels and put them together as a screen surround, you know, something like that. It's worth having stuff to delineate or frame your video with, rather than just have a floating screen, you know, with just black around it. I think it kind of degrades the whole design in a way. You know, even though the video plays big, it's still not solid scenery. It's still video, it's flat. You can make it look quite solid in some aspects, but to mix it with something that's tangible, that has tangible dimension to it, that can be huge. It can exemplify your design, you know, in a very positive manner. So I would tend to go about some of these designs, you know, just putting some kind of, even like a Versatube screen surround or blades. What are those things? What are those CHAUVET? Yeah, those things could make a great screen surround, you know. Anything, just try to frame your video. You know, don't just put it out there.
Any advice for making your video content more scenic?
Yeah, this is something that really was part of the whole revolution of media server design. Something that I really touched on a lot when I was first getting into it is I would always put frames. You know, I would have like just single columns of video panel, right? A single video panel column going up, going around, and we'd make these sort of screen surround looking things out of video elements. And then I would use tileable, like crown molding type of media or classic architecture. So what I ended up doing was I ended up buying and downloading a lot of classical tileable architecture elements online. Like there's thousands of them online now. You know, they have every type of version. They've got, you know, classic European, classic Asian, they've got Moorish, they've got Spanish, they've got Japanese. You can go through and find all these architectural elements and use them inside of, you know, very thin, very narrow video elements as a architectural piece and play them always as that. And then for songs, you use them as, you know, kinetic something, and then bring them back for, you know, the presenter part of the show as an architectural piece, and it'll play big. It'll play as a piece of architecture.
Would you do something like that, like you were saying, like on a separate, almost on a separate screen, or would you incorporate that a lot into, you know, one screen and that's done digitally?
I have done it on one screen, you know, but I like to use those elements on strips of stuff.
Yeah.
So like one strip of 7mm, you know, straight across, or 2 lines of 7mm. I mean, I have some photos of a show. I would go into it if you guys want to come up later. I'll be happy to show you. But where I use just a bunch of, there's tons of these really cool tileable architectural elements online that you can get, and they play really big as, you know, on strips. Just, you know, a strip of 7mm, strip of 10mm even, you know. And so if you design stuff like that, you can throw all kinds of architectural elements on them and then shift it at any time to, you know, cool, kinetic stuff, and it plays really big. It's really amazing how big that stuff plays, and people really appreciate it because it's something they don't always see in video element displays. You know, especially producers and stuff. You throw some of that stuff in there, it'll play big. Yeah.
Final question.
Yeah, yeah.
Give us the real story of the wardrobe malfunction.
Oh. The real story is I had no idea any of that stuff was happening. Alan was in the truck. He never told me anything about any of that stuff that was going to, I don't think he knew what was going to happen, but I think he knew something was going to happen because it was extremely important to black out when he said to black out. And so I was on the other end of that blackout, and he said to black out, and I blacked out. And then all I saw, I hear all this yelling in the truck, and everybody's freaking out.
You weren't even in a position to see what happened at that moment.
Yeah, I didn't even see it. I was like looking at the camera, then I'm like looking at my blackout button or my fader, and I'm like, he says blackout, I black out, and then I hear all this screaming, like blackout, blackout. I'm like, what are you screaming? I'm already blacked out. What's going on? You know, like there's a slight delay between, you know, when somebody tells you to, when the producer tells the LD to black out and they tell the programmer to black out, and the blackout happens, right? There's a very small delay. And I think they weren't quite anticipating the length of that delay. Like,
So
It seemed like an hour.
oh, I'm sure it did. Yeah.
Eternity.
Then all of a sudden, you know, and it was a split second, still a split second that it was like that. But it paved the way for a lot of change in broadcast.
So it was really a blackout malfunction.
No, because you would have seen it at any rate. I mean, they meant it to see.
Why would that be part of the show in black, though?
I know, no, it wasn't. It wasn't. No. They tried to.
Anything be planned in a black?
Yeah, it wasn't. But
I think.
Well, I'm just saying, to me, it's interesting that, you know, blackout or not, why would you ever
yeah, somebody knew.
like that unless you were going to?
Somebody knew that there was going to be something happening, but I don't think anyone knew what was going to happen. Just the blackout on the ending note. I don't know that it would be I am not sure. I mean, oh, put it this way. I went back to the trucks afterwards,
There you go.
and I'm just walking around, and I just saw the producer, Alex Coletti was the producer of that from MTV, just walking around, just like freaking out. Like you could tell he was stressed out. Like so, I'm
He
not.
wasn't happy, but no one was happy.
Yeah, I don't think really anyone knew that was going to happen. I really don't. I think they just
Do you think
were
they got
told.
like a fastball pulled on kind of thing? Like,
Maybe, but it was terrible. It was probably one of the single worst things to happen to broadcast in many years because
seemed like it had a catastrophic.
it did. It changed the fine from what used to be like $20,000 for an indecent exposure thing on live television to like $500,000 or some ridiculous thing like that. So it limited a lot of. That year, Victoria's Secret's show got canceled. I was slated to do that Victoria's Secret's that year, and it got canceled. And
Nothing really good came from that.
no, it was horrible, horrible. And but it made it so that kind of thing doesn't happen anymore on television.
Put more of a delay in, right?
I'm not.
Broadcast,
There's only like a 5-second delay at that point. Like there was only ever a 5-second delay at that point, and I don't know if it went from 5 to 10, or if some producers just on some shows where that could possibly happen have made it 10. But yeah, it changed things. And if you read about it in Wikipedia, you'll see all the things that happen as a result of it, and it's mind-blowing. It's absolutely mind-blowing what happened because of that one moment. And I was a part of it. Woohoo!
One other
Yeah.
question. So working with Patrick Woodruff, what was your biggest takeaway as far as from somebody who has done the magnitude of stuff that he's done, and you did that early on in
Yeah.
your career, that from a lighting perspective that you took forward from that? I mean, I'm sure you learned.
Oh yeah, learn heaps from Patrick. I think Patrick is a very classy individual. You know, he's very British. You know, he's very much like Mick. He talks just like Mick Jagger and stuff. I mean, I've had him over for dinner, cooked Thai for him and stuff. And he doesn't think much about work when he's not really on site. He's just a very sociable individual. You know, he's into, I think he has a different kind of touch. He doesn't inspire by like telling you what to do. He inspires by being your friend and going out and having a glass of wine and, you know, chit-chatting, and then you kind of develop a relationship with this person, and when you're programming, it's very natural feeling. Like when you're
conversation.
it's very easy at that point. And I think what I learned from Patrick was with programmers in particular, my own programmers that I'll use, is to try to develop a friendly relationship with them, make it not so much about the job as much as it is about, you know, a social aspect, really, and being friendly and developing a connection, which you then nurture. And then that connection opens up a lot of possibility for quicker, more efficient programming.
And trust.
And trust, exactly. And that's an important aspect. It's a lot more to design lights than just to know the technology aspect of it. And in a lot of businesses, to run a business, to manage people, to lead people, it's not so much about all the little details. It's more about the relationship, really. So, you know, focus on the relationship aspect. The technology is important, but everybody knows it, and everybody who's there should know it. So, you know, I think that's probably what I learned from Patrick is, you know, be friendly.
You did a good job learning that.
Thank you. Thank you, guys. So, really appreciate having me. Thank you. Thanks, guys.